picking up from where we left off, let's say that we wanted to define a function that could negate ourselves. What would that function look like if we wanted to declare it inside the class? Right, so we want to get negative us. So what's our type of our function going to be? What are we going to return? You negate a polynomial, you get a polynomial. How do I say that I want to do like operator negate? Well, again, we use our keyword operator and operator minus, and I'm not going to take in any arguments, right? Because that's how I specify the unary minus, negative us. And then const, because I shouldn't be modified when doing this operation. Right? Because if you do like negative a, does a change? No, right? A stays the same, so you're const, right? You give back a new version of a that's negative, right? Think about if you were doing something like this, like int x equals 5, negative x. After you do this line of code, what's the value of x? So on line 6, what's the value of x? It's 5, right? We didn't change x, right? This would just be like a temporary value that's created. So we can't change ourselves. That's why we're const. So we might make a new polynomial, right, called negative. And his value should start as being what? As us, right? So yeah, start this. And then how can we go through and negate each of its coefficients? So for loop, right? So for auto reference, right? Power and coefficient in whatever we called it. We called it coefficients. How can we make each coefficient negative? Power and coefficient dot second is equal to negative power and coefficient dot second. Oh, not through ourselves. We wanted to go through negative. You're right. Negative dot coefficients. There we go. And then at the end of the day, we could return negative. Not getting much feedback. What's wrong? What questions do you have about what we're doing here? Is it that we're doing something math-based with polynomials? Or is it like the operator syntax for declaring it? What's going wrong? Or is everyone just very tired today? Yeah. So we're saying, we're declaring that this function right here is our friend. So we're not declaring this function inside our class. We're saying this function, the one on the right-hand side, is our friend. So this one would count as both. So again, like, you know, here you can kind of see it maybe a little bit better. So here's operator plus equals, right? Is it inside of us? No, but to declare it my friend, I do it inside the class. And then over here, I apparently have a typo because that should be operator reference. Does that make sense? So notice it's not inside our class body where this function is defined or declared at, right? There's just some other function, operator plus, that does this. Over here, if you want to say somebody's your friend, you have to say that they're your friend inside your class declaration. So I'm saying this function up here at the top on line 12 is my friend. Does that make sense? So yeah, this is the declaration for the function. This is declaring that that function, I have to like specify like its entirety, is my friend. Friend gives it access to the private parts, right? It says access to the private members. We'll do one more in a second for our like operator minus, and we'll do that inside of the class. Yeah. So I didn't make it public. It's so down here, like coefficients is still a private member variable. This function, though, is special. He has special access to polynomial. He has full and complete access to polynomial, including the private members. Okay, so now let's say we wanted to define like polynomial reference operator minus equals, and it's going to take in a const polynomial reference right-hand side, right? So this is defining the function or declaring the function inside the class. So what could I do over here to do minus equals? But we could do even better as plus equals. What's another way of writing a minus b? A plus negative b, right? So we could do ourselves plus equals negative right-hand side. Right? And then we could return ourselves. Fantastic. So now I'm calling the plus equals function. Yeah. The return type is right here. Any questions here? Okay, and then if I wanted to define operator minus inside the class, what would the signature of operator minus be? What's our return type of operator minus? Polynomial, right? It's the name of the function, it's operator minus. And what do you accept as an argument? Well, another polynomial. Right-hand side. And do we change ourselves? Nope, so const. And again, you can use the same trick that we used earlier, where we can do like this section of code, but we make a copy of copy of ourselves, and then the copy, instead of doing a plus equals, does a minus equals, and then we can return the copy. Yeah. So the question is, what does the ampersand mean? Or is your question the ampersand or the asterisk? Yes, it does return. So this is a pointer. Its type is polynomial star. And so by putting a star in front of the pointer, it removes the star from the type. So star this type is just polynomial. And the function, instead of returning a copy of polynomial, will return a reference to it instead. So we end up returning a reference to ourselves. Any questions? So now let's say we want to be able to, yeah. So why do you get to return a reference to yourself? Again, we mentioned this earlier today, but this is so that we can do things like this if we feel sadistic enough. So that we can do this portion, like the plus equals plus. If we didn't return a reference to ourselves, this would not be possible. Okay, so now let's say we want to define the printing operator. So the way that we're going to have to do that is we have to include OStream, because that's the stream for printing. And then down here, the OStream operator returns an std : OStream reference, and it accepts as the first argument an std : OStream reference. We'll call this one out. And then it's going to return, or also accept as an argument, a const polynomial reference right-hand side. So this is going to allow us. Oh, my bad. Operator. This is now going to allow us to do things like see out our polynomial, right? So we're actually going to be able to write it directly to a stream. This guy is also going to need to be our friend. So we'll have to do the declaration inside the class. So I need to move him up to the top. And then we will also say that it is our friend inside of here, because we're going to need access to some of those coefficients. Yeah. We could have done one getter. So one thing that you need to be like wary about when you're doing like friendship and you know that it exists is you don't want to make everybody your friend. If in your design everybody's a friend of everybody else, the only thing I can say is you're doing it wrong, right? Because you're violating these interfaces by giving everybody that access to those private members. Because your public members are how you want people to interact with you. Private stuff is how you get things done. If we take, for example, a look at tic-tac-toe, the way that I want people to be able to interact with tic-tac-toe is I want them to be able to create a game, and I want them to be able to play a game. Everything else to make that game actually happen, that gameplay happen, is private, right? Another example to think about is think of a car. The public interfaces are the way that you interact with a car. So like the interfaces would be like the steering wheel would be a public member, or the gas pedal would be a public member. The brake would be a public member. The ignition, right, would be a public member. Things that would not be public members would be like the engine, or how when you like press the gas pedal, it makes the car go faster, whatever that functionality is, right? Those things are all internal implementation details and so should be private. So the friendship is only going to be used if we have things that are very, very tightly coupled to that class that still need access to the members. Again, in general, in this problem, I do not want to give people direct access to the coefficients, at least right now, right? But I still need to have a couple of functions that are going to be able to use them. These two, right? So only these two will be able to access the coefficients outside the class, and no one else will be able to. So friendship here is, again, still pretty minor. Yeah? It's written outside the class, so it is not a member of the class. Notice, outside the class, right? And this is just saying on line 24, this guy, right, this overloaded outstream operator, is my friend. Right? It's just saying that this guy up here on 14 is my friend. So let's say we want to go implement this. How do we go about printing out this polynomial to the screen? You have a for loop, right? So for const auto reference a power and coefficient in the right hand side dot coefficients. What should we do? Probably do something like out the well, we'll do this again because it makes our life easier. So we'd probably want to print something like out the coefficient, then write the word x, right? Probably more like x to the power space. So we're writing like ax squared plus bx squared plus c x cubed, or whatever our actual polynomial happens to be. Any questions here? Then at the end of the day, we need to return the stream. We return out. And this will allow us to print the polynomial to the screen. very easily. So now we can just, like if we have a polynomial, we can colon C out arrow arrow my polynomial, and it'll print the polynomial now. As long as you define an O-stream operator that takes in your guy as the right-hand side. You'll be able to do this for other types as well. What? Oh, we do need the plus. So it's going to look a little bit ugly because I'm not going to make it look pretty like you guys did. So there's going to be a hanging plus at the end. Sorry about that. And then we return out. This is supposed to return an O-stream reference. And this is supposed to return an O-stream reference. And this is supposed to be an O-stream reference. Made that mistake. Good now. So now we're able to print out. So we can try playing with our class a little bit. So what I might have over here in main is I might now include polynomial. Not inside the triangular brackets. And so now I can have a polynomial. And I probably need to include vector to make this happen. Oh, that actually... So you have a polynomial. What do you want your polynomial p to be? So what do you want for your constant value? Maybe it's like 10 plus 3x times 4x cubed. Oh, vector of a double. So we're calling this constructor back here the one that takes in the vector of doubles. And then for right now, we can just try printing it out. So we can do something like std : c out p, std : end out. And the reason that we're able to do this is because we define that O-stream operator. And so we can run this. So we get 10x to the 0 plus 3x to the 1 plus 4x squared. Right? Nothing surprising here. We can add polynomials together. So I might make another polynomial. Maybe this guy's name is now P1. And we might have another guy called P2. So we have a P2 here. And he might take in an std : map of std of integer to double. And so this guy is not going to accept a polynomial. So maybe he's like 3 to the 10 plus, I don't know, 5 to the -1. Right, so we can see out P2. And then we could do something like P1 plus P2 now works. I guess something that would have been kind of nice. It's 3 to 10, 5 to the -1. And we might also have, plus 6 to the 0. No, wait, we actually take it in as coefficient power. So power coefficient. So that's 3 to the, I want 0 to the, a little bit backwards. So that's kind of confusing. So now we get 16x to the 0 plus 3x to the 1 plus 4x squared plus 10x to the 3 plus negative 1x to the 5th. So I'm a little confused why he's coming out over here when he should have been like in order, because the map should be sorted by key. But anyway, does this make sense? Yeah. So you're saying like this probably would work. It was able to figure out the types. So one other thing that I want to show you is probably another thing you want to be able to do is evaluate the polynomial at some position and get its value. So if we wanted to, we probably want to be able to do like our polynomial, right? Like parentheses, some value. So that would require us to overload the parentheses operator. So over here we might have something like polynomial, oh no, it's not going to return. It's going to return a double operator parentheses, and on the right hand side we would need to take in a double x operator there we go. Now there's our function operator parentheses that takes in one argument. You can make multiple different versions of operator parentheses that take in a different number of arguments, but for our case we only need to take one. And the point of operator parentheses is to evaluate the polynomial at this point. So how do we go about doing that? All right, we can probably like take this. A double total starts out as being equal to 0. Then we go through each one of the coefficients and the powers, and oh, come on, there we go. How should we add the value to the total? So total plus equals. How is the exponential function? It's included in C math. If I say this, I want to include C math. So now I've included pow. So the first thing is the base, the second thing is the exponent. So it'd be like current just be like current coefficient times x to the power. Right, that would be the result of the polynomial. Does that make sense? You guys have any questions? Yes. No, he's one of our member methods. He's defined inside the class. He's a member. Right? So operator minus equals, like all the operator minuses are members, as well as operator parentheses. Are ones that are not members are operator plus equals, operator arrow for the O stream, and then operator plus. Those are not our friends. And if we wanted to, we could kind of go put all the people that aren't inside of us at the top if we wanted to. Make that a little bit consistent. So now we can evaluate the polynomial at some spot. So we'll do a simple polynomial to start with. We'll do a line. So maybe we have this guy over here. He's called line. And maybe he's like std colon. I'm just going to see if this works. He might be, maybe it's 3x, or 3 plus 4x. Yeah, I thought it would be. So it's going to be 3 plus 4x, right? So maybe we see this out. P3 at 2. So what's 3 plus 4x when evaluated at x equals 2? This is called line. 11. So we do 4 times 2, which is 8, right? Plus 11, or plus 3 is 11, so that seems about right. And if we run, I have a erroneous curly bracket. Oh, I didn't return something. I need to return the total. Go again. And hey, we got 11. Fantastic. Do you guys have any questions about operator overloading? I feel like everyone's asleep. It's not even Friday, guys. So one thing that I just want to remind you about with the operator overloading is use it where it makes sense. Operator overloading doesn't make sense in a lot of different areas, right? Doing overloaded operators in your connect for probably doesn't make sense unless you were wanting to overload operator brackets, which we can do that if you want to, like the square bracket operator. You want to be able to get your row at I, and you can go, you do square brackets. That works. I want to show one other thing first before we do operator brackets. So this is a fraction, right? And you can see that we've done a lot of stuff here from a previous class where we did plus equals plus, operator plus. One thing I want to show you though is operator double. So this is a casting operator, and this is the function that's going to be called when you want to cast the object of your specified type into the object here. So this is what's going to be used to cast a fraction into a double. Does that make sense? Okay, cool. The casting operators have to be defined as members of the class. They cannot be defined outside the class. If you want to be able to cast yourself to an int, define operator int inside yourself. You want to be able to cast yourself to a string, operator string. Absolutely. The type over here that you specify can be any type, user-defined or built-in. So over here, you can see that our fraction has a numerator and a denominator, right? So what do you think we would do in operator double to cast ourselves to our double value? Take the numerator and divide it by the denominator. So it's a pretty simple function, but you can see that we had to remember to do the casting on the elements themselves because they were both integers, and then we return the division. Yeah. So it depends. Your question, I want to do multiple operator pluses or something. Oh, so you want the right-hand side to be multiple different things, probably, or the left-hand side to be multiple different things, which will show. Yes, you could template it, absolutely, but be careful because then it's defined for everything, and that templated piece of code that you write needs to work for every single type where it makes sense, right? Because doing the plus doesn't always make sense for different types, right? Here we have a fraction, and if you did something like what you were specifying, we would now be able to do fraction plus string and have to be able to define that sort of. Not that it would really work though, but that code should work for all the things. So a lot of times you wouldn't use templating here because it wouldn't make sense in the most generalized cases. Some other things to mention over here, where are they? These are our friend. So notice that right now, if I want to do addition with a fraction, like my fraction plus 5, my fraction plus 7, my fraction plus another fraction, that's all fine because my fraction's always on the left-hand side. Again, if I want something else to show up on the left-hand side, I have to define one of the functions on the outside. So over here, we have operator plus and plus equals, that these all happen to be our friends, or at least this one happens to be our friends. This one isn't. And it's going to allow the integer to show up, oops, right here. This guy's our friend. These ones are all members. This is now going to allow us to do integer plus fraction, right? Because if I don't have it if I don't have this, I can only do fractions plus integers. I cannot do integers plus fractions. Given that we already have this operator plus defined for integers, what do you think you would write inside this function over here where you wanted to have the integer as the left-hand side instead of the right-hand side? Oh, so we'll go over here. So here's operator plus with ourselves on the left-hand side, right? So again, you see exactly what we did before. Fraction copy star this, copy plus equals right-hand side, return copy, just like we did before. Does that make sense? For operator plus, where operator plus equals, what it does is it turns the right-hand side into a fraction of that integer and then does the addition. Then we normalize ourselves to look pretty. So notice that we're kind of like lazy. Like one thing that you could have done is this one right here says return fraction left-hand side plus right-hand side. So we turn this integer into a fraction and then do the addition. That's fine. Or if we were kind of lazy, we could have just said return right-hand side plus left-hand side. But that works and does not do infinite recursion. Do you guys understand why? Do you have any questions here why this second version also works? Yeah. Yeah, I can get rid of line 93 and instead do line 94. So this right here, this is the function for fraction plus integer. This is the function for integer plus fraction. Which are like, that shouldn't matter, right? But in C, the types matter. In C++, the types matter. So this one right here is always going to do fraction plus integer. This one's always going to do integer plus fraction. And so the compiler needs to know how to call it. So that's why I had to do both of them. So over here, since we already have this operator plus defined, right, for fraction plus integer, what I do instead is I do fraction plus integer when I want to do integer plus fraction. And assuming that plus works defined in both directions, right, like a plus b is the same as b plus a, this is perfectly valid and legal. If the plussing is not symmetric where you can't change the order, then it would be legal. How many of you guys have taken like a 21A? Matrices, right? So you know that like matrix A plus matrix B, like A plus B is the same as B plus A, but A times B is not the same as B times A. So like you couldn't maybe cheat necessarily by doing it that way for the matrices if you were doing a matrix class. But like a scalar times a matrix and a matrix times a scalar, those could be done in either order. It doesn't matter, you get the same result. One other thing that I want to point out is, again, like if we want to define our overloaded operator, it pretty much looks the same as the last one. Again, we return an O-stream reference, we accept an O-stream reference, but the right-hand side this time is a fraction instead of being a polynomial. You guys have any questions? Okay. So that is operator overloading, and like printing it out, we just printed out the numerator divide by denominator, fancy stuff. That's operator overloading. We're completely done with that. Expect your next homework covering this topic next week. I know, right? This class is rough. I kind of promised you that at the beginning, but you'll hate me now, and you'll be really happy later after the class is over and you passed, because you'll actually know how to program. Or you'll know how to program a lot better than you currently do, for most of you. The next thing that we should do, because we have 15 minutes, is we will talk about iterators, I guess, because I don't think we have time to do justice to circular references. We'll talk about that on Friday. Oops, I didn't mean to close that. So you guys have seen the magical iterator, right? Because, I'll be honest, when I was taking this class with you, like I felt like I was dying as a student. Like I'd start the assignment the day it was given, I'd finish the day it was due. I'm working on it the entire time in between. So if you're feeling that way now, I know what it feels like. But I was a lot better at programming afterwards than a lot of my contemporaries who had other instructors who didn't push them so hard. So let's talk about magical iterators and what they actually do. And we'll come back and we'll do some like interesting looking stuff on some of the things that we've already done in the past. So iterators are kind of a generalization of the idea of going through the elements of a container. If you came from a C background, pretty much all the loops you ever would have written would have looked something like this. For I equals 0, I less than the length of your array, do something with array at I. So iterators generalize the concept of going through some container and then being able to access the element at that container. Some of the reasons why we can't do things like this for every single container is that not all containers are indexable by positions. You've already seen an example of this, which is map and also set, right? They're indexable by their keys, not by 0, 1, 2, 3, 4, 5, 6. Other examples might be something like a tree, or a graph where you need to find an element inside the tree or an element inside the graph. But again, they're not indexed based on position. So you can define iterators, and they are simply another class. What iterators normally have are two pieces of data inside them, but not all iterators have these two, but most do. The first is a reference to the object that they are iterating over. The second element is something to keep track of where the heck they're at inside the class, right? The iterators also tend to implement some of the following operators: unary star, arrow, plus plus, minus minus, equals equals, and not equals. In containers where it makes sense, sometimes you'll be able to do like things like plus, plus equals, minus. For example, like a vector iterator, you can do like my vector iterator plus 5, and that will move you 5 elements beyond wherever that iterator is currently at. But with a map iterator, you cannot do map plus 5. I map iterator plus 5 to get to the 5 elements after this one. Just not well defined, especially for an unordered map. The container class will also have methods to get an iterator over the class, such as begin and end, which you've already seen. One thing that you might also want to be able to do is make it so that you can do that for each loop for your object. If you want to be able to do this, you have to just define two methods, begin and end. And these functions have to return an iterator-like object. In C++, the types no longer of begin and end have to be the same. And if you define these two types, you'll be able to do that for the element-based for loop for your object. What this expression actually translates into is this guy over here on the right-hand side. So what it ends up doing is it will create like, so we have range equals the range expression. This is like your body. So you do for auto begin equals begin expression. So you call begin. End equals end expression, the end. So while the beginning iterator doesn't equal the ending iterator, right? Plus plus the beginning iterator. Go to the next one. Then the range element, which is like the actual value, is equal to star begin. So basically what's happening when you're writing these for each for loops for each element is it creates an iterator-based for loop in place of it and runs that instead. So it just says like, for iterator equals star begin. Iterator doesn't equal container end. Plus plus iterator, right? Element equals star iterator. That's all that it does. Any questions so far on iterators? We'll do an example in 1 minute of something a little bit more abstract, but also something you're probably familiar with if you come from a Python background. So you guys all know range, right? We're going to create a range class, and we're also going to create a range iterator over that class so we can move through the values 0, 1, 2, 3, 4. So what I want to do is go back to CLion. Oops, this is the wrong window. But we are on master. Oh, we're now in master. Okay, sorry, I just had to double check some things. Hold on 1 second. Apparently it's opening the wrong files. So the first things are, what do we need to represent a range? For those of you guys that haven't worked in Python, a range object represents the values between some start to some stop, counting by some step. So you can do something like for I in range, 10, 23, print I, 10, 13, 16, 19. So it represents that span of numbers. So what would you need to represent a range? I think I'm hearing some of them. You need 3 values, right? A start, a stop, and a step. So if we go over here to range.h, notice that we have a start, a stop, and a step, right? Let me just... And so what we can do over here is we can... I can always do that. So here we have 3 different versions of initialization, right? This one should be fairly easy. Why is this in range? Range. I'm not sure why this is throwing it inside of range iterator.h. Doesn't make sense. But anyway, so what should we do here in our constructor? Well, we should make, range start is equal to start. Range stop is equal to stop, right? And range step is equal to step. So now over here, we can be a little bit lazier on some of these other ones. When you call it with only a start and a stop, we're going to do a forward, again, a forward constructor. So we're going to call the top range constructor up here. When you only call range with a start and a stop, what does the step default to? 1. So we'll call this with start and stop and 1. I throw a comma in there. So what this constructor is doing is he's calling this constructor up here to do its work instead. And if you only provide a stop, again, we'll do a forwarding constructor. Again, we're going to run the top one. Our start should start at what? 0. Our stop is going to be our stop, and our step will be 1. Or if we were probably even better, we could just do this. Call this guy over here. Does this make sense? You guys have questions on what I just did? Yeah. Because now instead of calling this guy up here, I'm going to call the second guy, which is the one where we only gave a start and a stop. So I gave a start of 0, a stop of whatever was given, and we're going to stop at 1. Some other things that I want us to implement is we're just going to implement begin and end, and we're also going to create this OStream operator. If you're feeling really lazy about making the OStream operator, you can have CLine make it for you. So you can go to code, generate. I want a stream output operator. You select which things you want, and you say OK. And then it just prints them out kind of stupidly. It just says range start is range dot range start, stop is equal to range dot range stop, and step is equal to range dot range step. If we pop back over here, I'm not sure why this is in range iterator again. This should have been in range. Range.cpp, thank you. Now we have our OStream operator that it printed out. Does this make sense? Any questions? So now we need to make our iterators. And so we said that our iterators, they contained a couple of things, right? They would contain a reference to the object, and they would also contain something to keep track of where they're at. So what would we keep track of? What would we need to keep track of where we're at in the range? Not a trick question. Just an integer, right? So here we have our reference to our range object. Because how ranges work, we won't ever change our original range, so we're going to have a const reference to it. And then we have our integer, our position that we're at. Does this make sense? So over here, we have to go and implement our constructor. So over here, we need to include range iterator.h. Yes, we're going to do that. So we'll make range equal to the range that was passed in. And what should we make our position equal to? Right, range dot start. So back over here in our ranged class, notice we made range iterator our friend because our iterator is super duper tightly coupled with our class, right? But it might also make sense to, in this class, provide 3 other public methods: get start, get stop, get step, right? So we have 2 choices. We could make it a friend, or we could make these things public. Do you think in general people using the class would want to be able to get access to the start, stop, and step after they've created it? Yes, they might want to know what the start, stop, and step of a given range is, or they have no use for that information and would never want it ever. I think they would probably want it, right? I mean, like, there's pretty good odds if you're just passed an arbitrary range, you might have some questions about that range start or stop. So what we might have is, instead of making it a friend, we could have some code and generate some getters. Probably over all of them. Great, they're there. And now what we can do, because we have these getters, is again, we don't need to be a friend anymore. And now back here in range iterator.cpp, I can't say range.range start, but I can say range.get range start to get the value. So again, like when you're asking yourself, like, should this thing be like a public member and people should have access to it, or whether you need to use friendship, ask yourself whether a lot of people might want to use this thing. A lot of people might use this information, and is giving it out going to hurt you? If your answer is yeah, a lot of people probably are going to want this, and it's not going to hurt me, put some getters on there. If you're like, man, people shouldn't know what's going on behind the scenes or how this stuff is working, but this class is really tightly coupled to me, it's really, really closely related, and it needs access to those things to get it done, then you would use the friendship. So hopefully it's a little bit more clear about what's supposed to happen. So this would put us at the range start. This guy over here, he's going to put us range, and our position will be whatever was specified. So if we're lazy, now that we have this second one, the first one we can do is this way. We can do the for constructor, range iterator. Range iterator, pass in range, and pass in range dot get range start. And if your question is like, well, why, Matthew, do you keep preferring to do these forwarding constructors? It's because if one of them is wrong, I only have to fix one of them, right? This guy, right? If I've screwed up somehow, I just have to fix this one, right? Assuming I'm passing the right arguments to it. So that means I only have to make my change in a single area, right? Whereas if I do the exact same copy and pasted piece of code in multiple separate areas and I screw up, gotta go change them all. We will pick up with this on Friday, but we'll put it on pause to begin with. We'll talk about this circular inclusion problem, how to fix it, and then we'll get back into iterators.